Hello everyone, this video is about nuclear reactions. So today we're going to learn about how to write a nuclear equation. So let's start. First of all, we would like to go over the element symbol. So this is the format we have to write for all the elements, right? Mass number always goes on top, atomic number on the bottom, and then we write down the symbol of the element, right? So always remember, in nuclear reactions the mass numbers and atomic numbers are conserved, right? So that means the sum total of masses on the left hand side of the equation, the equation is separated by an arrow, right, is equal to the sum of mass numbers on the right hand side of the equation, and same thing is true for the atomic numbers, right? So the atomic numbers on both sides of the equation should also match. Okay? So let's do the first type of problem in which you have to predict the daughter nucleus. Okay? So here, so this is the problem number 11 on worksheet number 6. So let's do this problem and see if we can do that. So we are given an isotope of plutonium, right? The mass number is 239 and the atomic number is 94. That decays into a daughter nucleus, so that is our parent nuclide. So it decays into some element, we don't know that yet, we have to predict that, and it gives out an alpha particle. So this is an alpha particle. So this is an alpha decay. So let's find out what kind of particle was emitted. Now look, we always start with the atomic numbers. So the total number, atomic number on the left hand side of the equation, remember this arrow separates the two sides of the equation. So we have 94 on this side. This stands for equal to, and on this side we don't know the atomic number of the daughter nucleus yet, but we know the atomic number of an alpha particle, so that is 2. So if I solve this equation, I know I have to put 92 here, right? So the atomic number of the daughter nucleus is 92. Next thing what we're going to do is we are going to look at our periodic table and find out the element that has atomic number 92. So that would be uranium and the symbol is U, right? So we always look at the periodic table for the atomic number. Never ever get the mass number from the periodic table. So that element is uranium, so I'm gonna write U. Next we figure out the mass number after we have predicted the daughter nucleus, right? So again we're gonna do the same thing with the mass numbers. On this side the mass number is 239, and on this side we don't know the mass number of the daughter nucleus, but we know the mass number of the alpha particle, which is 4, right? So if I solve that equation, I know it's gonna be 235, right? So I will write down the mass number of uranium, which is 235. So this is how I predict the daughter nucleus, right? Next, let's do another example. So this time we have iodine, and in this example we are actually predicting the type of decay. So there are two types of problems, right? In the first you have to predict the type of the daughter nucleus, and in this one we will predict the type of decay, right? So we know we're gonna start with the atomic numbers first, right? So let's write down the atomic numbers. So on this side, so this is our equal to, so we have atomic number of 53 on this side. This is equal to 54 plus blank, right? So now if I add a -1 to 54, I know it's going to be equal to 53, right? So the particle that was emitted has a charge of -1, right? Now let's see the mass numbers, right? So we have 129 on this side and 129 on this side. So we can say that the mass of the emitted particle is 0, right? Because the masses are already balanced. So I'm going to put a 0 here. Now think of a particle that has a 0 mass and a charge of -1. That would be a beta particle, right? So I can either write it like that, or I can also write it like this with a beta symbol, right? So this would be a beta decay. Okay. Now let's try to do some problems from the worksheet, right? So I'm going to do talk about the neutron initiated fission reaction. Remember, fission is when a bigger nucleus splits into smaller nuclei, right? So whenever you see the word initiated or bombardment, so these are the two things that you need to look for before you write the nuclear equation. Initiated and bombardment means the particle was hit on the parent nucleus. So neutron initiated fission of U-235. So this is our parent nucleus, right? So you write down uranium-235. Remember, this is an isotope. So we will write the mass number on top. Then uranium. Uranium has an atomic number of 92. So this is the parent nucleus that is given to you. Next, you write down the particle that was thrown at U-235, because this reaction got started with neutrons, right? You have to hit the neutron on uranium. That is what initiated means, right? So next, write down the symbol of a neutron. Now this is how the reaction starts. We have the reactants on the left hand side of the equation. Next, we have to see what was made, what are the products, right? On this right side of the arrow, it releases 2 neutrons. So we write 2 and then the symbol of the neutron. Don't forget that 2, right? 2 neutrons were released and it forms a cesium-144 nucleus. That's a daughter nucleus, one of the daughter nucleus. So I'm going to write 144 cesium. Now let's look at the atomic number of cesium from the periodic table. So cesium, the atomic number is 55. So let's write down 55 for the atomic number, right? Now next, you have to figure out what was the other daughter nucleus that was emitted, right? So you have to predict the other particle. So what we do is, we're gonna again do the math, right? So let's do this here on a piece of paper. Now look, so we have, right? So let's add the mass numbers. So we have 235 on this side and then 1 neutron. So this is what I have on the left hand side, and on the other side of the equation I have 2 neutrons. Mass of 1 neutron is 1, and then we have 2 neutrons, so 2 times 1. Then the mass number of cesium, which is 144, and then the mass number of the new daughter nucleus, right? So this is for the mass numbers, because mass number is conserved, right? Now let's see the atomic numbers. On this side we have 92 plus 0. The mass atomic number of neutron is 0. and on this side we have 2 neutrons, so 2 times 0 plus atomic number of cesium, which is 55, and then the atomic number of the other daughter nucleus, right? So if you do the math, you're gonna see this atomic number is 37, right? So this would be 37. Now I know that the atomic number of the element is 37, right? So now look at the periodic table and figure out the atomic number 37, which is rubidium, Rb, right? So let's write rubidium here, and then if you calculate the atomic mass numbers, right, you will see the mass number of rubidium comes out to be 90, and then we will write down 90 here, right? So this is how we do the nuclear reactions. The key is you have to balance the mass numbers on both sides of the equation and balance the atomic numbers on both sides of the equation, and then once you figure out the atomic number of the daughter nucleus, you can simply look into the periodic table and figure the element out. Remember, never ever to use the mass numbers to check the element from the periodic table. Hope that video is helpful. Thank you.